In this lesson, we're going to be talking about 8-3, which is writing equations. And then in the next lesson, we'll move on to 8-4. So in 8-3, it's only the front page of the notes. The back side will be 8-4. What is the essential question? What is the difference between an expression and an equation? And that answer is equations have equal signs and expressions don't. All right. Now, we're learning how to translate sentences into equations. And there are three categories. The first category is you got to pay attention to the mathy words. What are the mathy words that you need to look for? Well, you need to look for words that mean addition, subtraction, multiplication, and division. For addition, these are just a few. Together, added to, combined, sum, all in all, increased by, total, and ... meaning there are so many other words that mean addition in math. For subtraction, we have another set of words, minus, less than, or fewer than, the difference, reduce, take away, and ... meaning there are so many more words out there that mean to subtract. For multiplication, we have double, the word by, triple, the word twice, product, each group, and ... which you know means there are so many more words. And the final one, which is division, equal sharing, per, percent, quotient of, half, and again, ... which means there are so many more words. So just pay attention as you're reading and pick up on those words. Choosing a variable. There's 2 points to this. The first point is use a lowercase variable to define the missing value. We are looking for the missing value. So use lowercase for that. The second point is use a variable that would make sense with the story, such as if they're looking for the cost, use lowercase c. If they're looking for how many apples, use lowercase a. And if they're looking for a number that they don't know, number starts with n, so use n. Now you might want to use x sometimes too, but it doesn't really matter. But when you start dealing with the Google Forms, if you're looking for a certain amount of bananas, you want to put b equals 10 and not r equals 10. So b would make the most sense. Stepping into the last section here, make an equation. Translate word phrases into an algebraic equation, noting where the equal sign goes. Here's some words for equal signs. Is, balance of, result of, and there are so many others. Let's take a look at this first one. 5 times x minus 4 is 2. So the word is stands out to me as the equal sign, and we have the is right here. It says 5 times x, and you can see that we have 5 times x here, minus 4, and I am subtracting 4 from the 5x. And it says is 2, so 2 would go on the other side of the equal sign, right here. The next example, we have twice. Twice means 2, and that's 2 of something that we need to multiply. Well, we're multiplying twice the sum. Sum means to add, and we have the addition sign right here. What are we adding together? X and 5. So you can see the x and the 5 are adding together, and we want to know what twice the sum of that is. So first you have to add these and then multiply it by 2. And then we have the fancy word is, which is the equal sign, 10. Let's take what we learned and apply it to these examples. First example, Mr. Katosh is renting a batting cage for $20 per hour, plus 15 cents per pitch. His budget is $41. How many pitches would he receive in an hour? So let's take a look at what his budget is. His budget is, and that's indicating what it's going to equal. So let's put 41 down here is equal to something. Well, what are we asking for? How many pitches would he receive in an hour? How many hours? 1 hour. Well, that 1 hour rental is $20 per hour, so let's write down $20 plus, we see the plus word right here, 15 cents per pitch. And that's exactly what we're asking for. We want to know how many pitches. So we'll put 15 cents P. P is a great variable for pitches. And now we will take what we learned in the previous lesson to solve this. We'll locate the variable. We'll see that we have a coefficient we need to deal with here, and we have a constant to deal with first. So let's begin with the constant. We're going to add negative 20 to both sides. And that's going to give us $21 is equal to 15 cents P. And now to get rid of the coefficient, we're going to divide it by 15 cents on both sides. And now this is definitely a calculator problem, 21 divided by 15 cents. And when you put it in your calculator, you're going to get P is equal to 140. Now what does that stand for? That's the amount of pitches he's going to receive in 1 hour. Now think about that for a second. You got 60 minutes in an hour. And that means you're getting more than 2 pitches per minute. So he'll probably be pretty tired out. Moving on to number 2. Emma is making 5 pizzas in Dutch ovens. Of the $30 spent on pepperoni and cheese, Emma spent $3 per pizza on the meat ingredient. What is the meat ingredient? It's the pepperoni. How much was spent on the cheese? So we want to know what cheese is. So a great variable for cheese is C. But she's not just making 1 pizza, she's making 5 pizzas. So we're going to do 5 parentheses, and the parentheses is going to stand for 1 pizza. Well, what's in 1 pizza? There's $3 per pizza for the meat ingredient, so we're going to put a 3 here, plus the cheese ingredient. And we don't know how much she is spending on the cheese per pizza. Now what's all of this supposed to be totaling? Well, she spent a total of $30. And now you can see we use the distributive property. 5 times 3 is 15, and 5 times C is 5C. We bring down the plus sign, and we get $30. Now you can see we have a variable right here. We have a coefficient of 5, and we are adding a constant of 15. Let's get rid of the constant first. We'll add a negative 15 to this side as well as this side. We're going to get 5C is equal to 15. Then we'll divide by 5 on both sides, and we'll find that C is 3, standing for she's spending $3 on each pizza for cheese. Moving to our next example, the bowling alley. The bowling alley is charged for the number of games played and shoes rented. Cody, now listen to this, Cody and 3 friends. Well, how many humans is that are bowling? There are 4. So we just want to make sure we remember that. Their total bill was $58. So they're going to spend a bunch of money here, and their total bill is going to be $58. They each paid $4 for shoes. Okay, so this is the 4 bowlers. We'll put parentheses here, and the parentheses stands for each player. Well, they spent $4 on shoes, and if they share the game rate equally, what did each of them pay per game? Well, a great variable for a game of bowling would be G, because we want to know what the game rate is. So now we begin with the distributive property. 4 times 4 is 16, and 4 times G is 4G. We locate that variable. We see that we have a coefficient to deal with, and we have a constant to deal with. We'll deal with the constant first. We'll add a negative 16 to both sides, and we get 4g is equal to 42. We'll divide both sides by 4, and in the calculator, you're going to get g is equal to 10 and 5/10. But that's a terrible answer for a money problem, because we are missing the pennies. So the official answer will be $10.50 when it has to do with money. And now finally, the fourth one. On number 4, it says the length of a rectangle. When I have problems like this, I'll just draw something. Here's a rectangle. The length of it is usually this longer part from here to here, and it says that it's 4 times its width. So I'll take the width and I'll multiply it by 4. Find the perimeter. Perimeter means from one corner all the way around. Okay, so what is the width? We don't know, so we're going to put a W there for the width. Now, when you're dealing with perimeter back in elementary school, you know that there are 2 lengths and 2 widths. So if you set this up as 2 times a length plus a width, because there's 2 pairs of those, all of them have to equal a perimeter of 50, and it says it right at the end. What is the width of the rectangle with a perimeter of 50? Okay, so now we'll combine like terms in the inside. 4w plus w is 5w's. We'll distribute 2 times 5w is 10w, and then we'll divide out the coefficient and get w is 5. Now, would this make sense? If we redraw the rectangle, the length would be 20, the width would be 5, so we got 20 and 5. If you add up all those, it is 50. All right, we got a couple problems here for you. You're going to pause the video and you're going to try out all 3 of these at one time. What I'd like you to do before solving them is just write out an equation based on how we learned it. Do not solve it. I want you to unpause the video when you got all 3 so you can see if you wrote them correctly. Pause the video now. All right, here are the answers of writing the equations. Now, you might not have exactly these things. You might have on the first one something that looks like this. And that would be fine. That's just turned around. But you definitely have to have a minus 15 and not 15 minus. That would be wrong because of the words less than. Be careful of that. On number 2, it talks about Tad's goal to have $950 in a savings account, and that's definitely the total, so 950 equals. And he already has 220, and that's fine. And then he started a penguin egg ranching business for which he fetches $20 per carton of 6 eggs. Now, the 6 eggs seems like it's important, but it's not, because the question says how many cartons need to be sold. Well, cartons starts with the letter C, so if it's $20 per carton, I put 20C. Now, it could be written like this, or you could possibly have written like this, or some other combination. And why can we switch these back and forth, this way or that way? Because of the commutative property of addition. You can add out of order. And the last one, Jerry's 18 golfers at the ASI. So it's talking about, in this story, each player enters a school tournament. The tournament fee minus the greens fee is $35. Is charged to each player for an entry total of $396 for all 18 players. So you can see I'm setting up 18, and then each player is going to be inside here. Each player has to have the tournament fee minus their $35 green fee. So that's set up appropriately, and all of this is equaling the 396. All right, to solve all of these, you would just use your inverse operations. Let's take a look at the first one. So we want to deal with this subtracting 15, so I'll use the additive inverse on it first. I'll add 15 to both sides and get 3n is equal to 18, then divide by 3 and get n is 6. Now if that went a little bit quick for you, you can always rewind it and see how that's going on. The second one, we're looking for how many cartons, and we are simply going to add the negative 220 to both sides. There really is not enough room here to do this. So we have 730 left is equal to 20c. Then we'll divide by 20 on both sides, and then I'll use that calculator again, and I'll just type in 730 divided by 20 is c is equal to 36.5. Well, you can't sell a half of a carton, so Tad's going to have to sell 37 cartons. And now the last one, Jerry. I like to always use the the additive inverse on subtraction signs, and now the distributive property. 18t, back to the calculator. Please don't put in negatives, because you know that a positive times a negative is a negative. That would be a waste of time. And 18 times 35 is 630. Okay, and then we'll get rid of the 630 by adding a negative 630 to both sides. Oops, I made a mistake here. I just caught it. Sorry, I was delaying because I was thinking. All right, let's back this up. I forgot the negative sign right here, because a positive times a negative is a negative. All right, onward. Add a positive 630 to both sides. That straightens it out. And we get 18t is equal to 1026. We'll divide both sides by 18. And we get 57. So each player's tournament fee is $57. All right. When you flip the notes over, this is going to be 8-4. So we're going to stop here, and we'll go right down to the assignment of 8-3. Make sure you put your first name, your last name, the date, and the period, and then you just start solving these. I'll do the first one with you. 5 less than 3 times a number is 13. So we're going to take 3 times a number, n. We're going to use n as the variable. So 3n, take away that 5 because it says 5 less than, is 13. And then it says then solve. So I'm going to do additive inverse here. And I'm going to get rid of the negative 5 by adding 5 to both sides. And I got 3n is equal to 18. I'll divide by 3. And n is 6. So in the forms, I'll write n. N is 6. N equals 6. The rest of these, they're talking about finding a number. So n is your variable, n is your variable, n again is your variable, another looking for a number, looking for a number, looking for a number, and looking for a number. So it looks like you're going to be using n for your variables all the way down through 8 or 9.